In this video, I will explain the digital logic design conversion. So, conversion of numbers into different forms, just like from decimal to binary, from binary to decimal, from octal to decimal, from octal to hexadecimal. So the first conversion is decimal to binary. In this conversion, we are given a number 33 with a base of 10. So we can divide the number with 2 and we get the answer 16. Further, we can divide the number with 2, and if when it is an even number, we get the remainder of 0 because the even numbers are completely divisible by 2. But when it is an odd number, we get a remainder 1. So we can take this number and move it from the bottom to the top, and we'll get a number just like this, 1 0 0 0 0 1 with the base of 2, which is a binary number of the decimal number 33. The next is decimal to octal conversions. The same number we are given 33 with a base of 10. In decimal to octal conversions, we divide the number with 8 instead of 2. So when we divide the number with 8, we get the 4 in case of 33. 8 4s are 32, and we get a remainder of 1. Furthermore, we cannot divide 4 with 8, so we'll get a remainder of 4. Same like decimal to binary conversion, we take the number from bottom to top, and in this case it will be 41 with the power of 8, which is an octal number. The next is decimal to hexadecimal conversions. In the same number 33 with the base of power 10, in this the difference is only we divide the number with 16. When we divide the number with 16, it is 32, which is remainder of we get a remainder of 1, and further we cannot divide 2 with 16, so we get a remainder of 2. Bottom to top, it's 21 to the power to the base of 16, which is a hexadecimal number. The next conversion is binary to decimal conversions. In this conversion, we got a number 1110101 with the base of 2. To convert a binary number into a decimal number, we'll multiply it with the 2 and increment the power of 2 respectively in each step. First of all, we got 2 raised to the power of 0, and respectively this value is increasing with an increment of 1. When there is 1 here, we can write the power value of 2, but when it is 0, the 0 will multiply with the power value and the result will also be 0. And in each step we'll double the value which was before. So in this case it was 1 multiplied by 2, then in the next step it will be 2 when there is 0 here, and multiplying 2 with 2, we get a 4, and in the next step we'll get a 8. In the next step we'll get 16, 32 and 64. When we add these numbers, we'll get a number. In this case we get a number 117 with a base of power 10, and it is the decimal number of binary number 1110101 base of 2. In the binary to octal conversion, we'll divide the binary number into the group of 3, because the octal number we have that base of 2 powers 3. So we'll convert it into a group of 3 and convert this group into the decimal code of the number. In this case it is 101, which is the binary of decimal number 5. In case of 110, it is the binary of decimal number 6 and 1, so we'll write it as 165 base of 8 because it is an octal number. To convert the binary number to hexadecimal, we'll repeat the same step we did in the binary to octal, but in this case we'll divide it into the groups of 4 because hexadecimal have a range of 2 power 4. So and the same step we'll do it here. We take the binary number and convert it into the decimal form of it. In case of 0101, it is 5. In case of 111, it is 7. So write it like that with the base of 16, which is hexadecimal number. To convert an octal number to decimal number, we take the number from right to left consecutively and multiply it with the power of 8. We'll take the power of 8 and increment it with each step, just like we did for 2 before. In this case the value of 8 is increasing, and by multiplying it we'll get a value when we add these values, we'll get a number. In this case we got 451 base of 10, which is a decimal number. To convert an octal number to binary, we write it like that, 703, and convert each decimal number into its binary form. The binary code of decimal 7 is 111, the binary code of 0 is 000, the of 3 is 011, and we can write it like that with the base of 2, which is a binary number. To convert a octal number to hexadecimal, we'll repeat the same steps, but it's a little tricky that way. We'll convert first the octal to binary number. Okay, octal to binary number, and after converting it into a binary number, we'll separate it into groups of 4, because hexadecimal have range of 2 power 4. So converting it into 4 groups, we can then convert it into the hexadecimal number. In case of 0011 it is 3, in case of 1100 it is C, and in case of 1 it is 1, and we can write it like that with the base of 16, which is a hexadecimal number. To convert a hexadecimal number to a decimal number, we'll take the number from right to left and change the characters into the digits. The decimal number of F is 15, of A it is 10, and we can multiply it with 16 and increment the power of 16 respectively in each step to get a number. When we add these numbers, we'll get a decimal number. In this case it is 431 with the base of 10, which is a decimal number. To convert a hexadecimal to binary, we'll take the number and convert it digit by digit. In this case, the binary code of F is 1111, the binary code of A it is 1010, the binary code of 1 is 00 and 01. When we write it like that, we get a binary number with the base of 2. To convert a number into octal form from hexadecimal form, we need to do 2 steps here. First, we can convert the number digit by digit into the hexadecimal binary digit, because hexadecimal has the range of 2 power 4, so we can convert it into digits of 4, and after that we can separate these all digits into the pair of 3, because octal number has range 2 powers 3. So after separating it into the groups of 3, we can then convert it. In this case it is 111, which is 7, 101, which is 5, 110, which is 6, and 001, which is 0, and we can write it like that, 657 with the base of 8, which is an octal number. And in the end we have arranged all these conversions into a table, and it would be easier that way to see which number we are converting and from which number it is being converted.